Right, so let's talk about rules of divisibility. And we are going to go through these examples here, which the question says, which of the following divisions result in integers? And the objective is not to actually carry out the division. The objective is to just inspect the numbers and see which of these result in integers, that is, which of these numbers perfectly divide the other numbers. And if necessary, we can also do the divisions, but that's not the point. The point is to do these problems quickly and get the answer without the actual division. So that's why we have these rules of divisibility that we are going to go over with this example. So we have these 7 questions. We are going to go through them one by one, and rules of divisibility will help us to decide which of these result in integers and which of these don't. So let's go step by step. So the first one, it says 56 divided by 2. So we need to know the rule of divisibility of 2. So a number is divisible by 2. Let me write this down. Number is divisible by 2 if it ends in an even number. Even number. So even numbers are, we know that this is 0, 2, 4, 6, 8. These are the even numbers. So if a number ends in one of these numbers, then it is divisible by 2, otherwise it is not. So we have 56 here. It ends in a 6, which is an even number. Therefore, 56 is divisible by 2. It is divisible by 2, and therefore 56 divided by 2, yes, it will result in an integer. This will result in an integer. Let's take an example of something that is not divisible by 2. Let's say suppose 115 divided by 2. This number ends in a 5. This is not an even number. 5 is not an even number. So this 115 is not divisible by 2 here. Okay, let's take the other example. Okay, this one is interesting. So this is 732 divided by 3. Now we can do the actual division, but that's not the point. We want to come up with a quick and easy way of just checking if the number is divisible by 3 without actual division. So the rule of divisibility for 3 goes as follows. So add the individual numbers. Add the individual numbers, or I should say digits, in the given number. If this addition is divisible by 3, then the original number is also divisible by 3. So let's see how to apply this rule here. 732 is our number. So 7 plus 3 plus 2, this is 12. And we know that this 12 is divisible by 3, or we can again use the rule here. 12 is basically 1 plus 2. So it is divisible by 3. 12 is divisible by 3, we know separately, or this 1 plus 2 is also 3. That is also divisible by 3. So 732 is divisible by 3. So this is divisible by 3, yes. Let's take an example of a number that is not divisible by 3. Let's say 97. So 9 plus 7 is 16. 16 is not divisible by 3, or another way to see this is 1 plus 6 is equal to 7, and 7 is definitely not divisible by 3. So you can recursively keep applying this number, or rather this rule, if the number is not immediately observable as divisible. So 97 is not divisible by 3. Just to reinforce this point, let's take an even bigger number. I'm going to write a random number here. 1 2 3 4 5 6 7 8 9 7 5 3, whatever, some huge number. Is this divisible by 3 or not? Let's see. So 1 plus 2 is 3 plus 3 is 6 plus 4 is 10 plus 5 is 15. Number is 15 here. 6 plus 7 13 plus 8 21 plus 9 30. So this is 30. And 7 plus 5 12 plus 3 is 15. You note that I am stopping here basically at a number. I've been doing this for a while. So you stop when the summation that you get is divisible by 3. So the sum of these 5 numbers is 15. I know that it is divisible by 3, so let's just write it here. 6 plus 7 plus 8 plus 9, this is 30. I know that it is divisible by 3, so let's write that here instead of carrying a huge addition. And 7 plus 5 is 12 plus 3 is 15. So each of these individual numbers, 15, 30 and 50, they are all divisible by 3. So their addition is divisible by 3. So this number is divisible by 3. Okay, or we can add all the numbers and their addition will be 60. The addition of all of these is 60. 60 is clearly divisible by 3. So this whole number is divisible by 3. So that's the power of this rule, that you can be given some 20, 30, 40 digit number and you don't need to actually do the division, which can go wrong or it could be slow, but you can calculate if the number is divisible by 3. Let's go to the next example. 65779 divided by 3. 65779 divided by 3. Let's add the numbers. 6 plus 5 plus 7 plus 7 plus 9. This is 11 plus 7 is 18. 25, 32. So this is 32. Therefore, because 32 is not divisible by 3, 65779 is not divisible by 3. So this one is not divisible by 3. The fourth one is simple. Division by 5 is always simple, that you just need to check the last digit. If it is 0 or 5, it is divisible by 5. If it is not, it is not. So I will write it as yes. Just let's formally state the rule here. Fourth one is 1500655 divided by 5. Let's write that down. So we need to check last digit at 0 or 5. This implies number is divisible by 5. Okay, that was straightforward. Divisibility by 5 is straightforward. This one is interesting. 6786754 divided by 4. 6786754. I hope I wrote that right. Divided by 4. Now divisibility by 4 is slightly more difficult than divisibility by 2, but it's still straightforward. We don't need to divide the entire number by 4. We need to look at the last 2 digits. So it's an extension of what we did for the case of division by 2, when we looked at only the last digit and we checked if it was even or odd, which is basically checking if the number is divisible by 2 or not. Here we need to look at the last 2 numbers. We'll see why this is sufficient, but let's look at the last 2 numbers right now. And the rule says that if the number found by the last 2 digits is divisible by 4, then the original number is also divisible by 4. So that's the rule, and let's see why this thing works. Let's first see if this gives us what we are looking for. So this 54 is not divisible by 4. Is not divisible by. I'm going to introduce notation that saves me some writing. Not divisible by 4. And the notation for that is, it says 4 is not divisible, 4 does not divide 54. If I want to say 4 divides a number, say 4 divides 52, then I will say 4 divides 52. This is a notation for divides. And this is a notation for does not divide. So because we know that 54 is not divisible by 4, this entire number is not divisible by 4. And it's easy to see why this something like this should hold, because our number is 6786754, which is 6786700 plus 54. Now this first number here is a multiple of 100. This is divisible by 100. Therefore also divisible by 4, because 100 is divisible by 4. So all that matters is the last two digits. If that part is divisible by 4, then the entire number is divisible by 4. If not, then it's not. Similarly, you can see that a number is divisible by 8 if its last 3 digits, the number that is found by its last 3 digits, is divisible by 8. And the logic is same. If the last 3 digits form a number and the rest of the number is divisible by 1000, so all that matters is the last 3 digits. And for same thing for any higher power of 2. Basically, number is divisible by 16 if the last 4 digits are divisible by 16, and so on. We are not going to go into the details of that, but just for your information that the logic still continues to apply. So this number is not divisible by 4. This example is now interesting. Divisibility by 11. So let's talk about this. 4534 divided by 11. We want to know if 11 divides this number without actually doing the division. So the rule for 11 is slightly different from other rules. So let's write this number 4534. We take the addition of the numbers in the even places and the addition of the numbers in the odd places. So and if their difference is divisible by 11, then the entire number is divisible by 11. So this 4 plus 3 is 7, 5 plus 4 is 9, and this 7 minus 9 or 9 minus 7, whichever way you write it, 11 does not divide this. Therefore 11 does not divide 4534. So we'll go over one more example that will clarify this. 846978. Let's see. Eight four six nine seven eight divided by 11. We want to see if the division is possible, or rather if the division gives an integer. 846978. So let's take the alternate numbers on the even places, and these are the numbers on the odd places. 8 plus 6 is 14, plus 7 is 21, and 4 plus 9 is 13, plus 8 is again 21, and 21 minus 21 is 0, and 11 definitely divides 0. So 11 divides 846, or rather 86, what am I writing, 846978. So this number is divisible. This takes a little bit of getting used to, and this takes a little bit of practice to get the division by 11, but it is straightforward, and spend maybe a few minutes to understand what we are doing here. We are adding numbers in the even places and odd places, and if their difference is divisible by 11, then the number is divisible by 11. There is a similar test of divisibility by 9. It's just like the divisibility by 3. So we have a number is divisible by 3 if the sum of its digits is divisible by 3. Same rule works for divisibility by 9. If a number is divisible by 9, then its sum of digits is divisible by 9, and vice versa. So it's an if and only if condition, or that's exactly what we want. So let's take a quick example here. Let's take 729. So 7 plus 2 plus 9 is 18, and 9 divides 18. Therefore 9 divides 729. So the rule is so divisibility by 9. If the sum of digits is divisible by 9, then the original number, the given number, is also divisible by 9. Is divisible by 9. So that's the divisibility by 9. Divisibility by 10 is straightforward. If the last digit is 0, it is divisible, otherwise it is not. There are slightly more complex tests for divisibility for other numbers. Say for example 6. Number is divisible by 6 if it is divisible by both 2 and 3. And if it is divisible by 2, then it has to end in an even number. And we know if the sum of digits is divisible by 3, then the number is divisible by 3. And therefore we can check divisibility by 6. Divisibility by 7, there is a rule, but it's slightly complex and it's not it gets some practice to use it, and it's not very important, so I'm not mentioning that here. So that's the rules of divisibility by small numbers.